For decades, the maps we drew of our solar system were based on a set of computer models that turned out to be billions of miles away from the truth. In the 1980s and 90s, scientists used magnetohydrodynamic simulations to predict the shape of our cosmic sanctuary. They believed the sun produced a heliosphere, a perfectly symmetrical bubble of plasma that ended abruptly at 90 astronomical units. This line was taught as a static, sharp boundary. It was the point where the outward pressure of the solar wind was thought to be perfectly neutralized by the pressure of the interstellar medium. But in 2012, and again in 2018, Voyager 1 and 2 physically reached that coordinate. They found that the boundary line we had drawn on our maps simply wasn't there. These discoveries didn't come from a modern flagship mission. They came from Voyager, a 1977 design built with analog logic and a total memory capacity of just 68 kilobytes. We spent years refining supercomputer models of the galaxy, only to have the physical reality recorded by a machine that runs on less memory than a basic digital image. Voyager 1 eventually detected the end of the sun's influence at 121 astronomical units. Our models had missed the mark by 2.4 billion miles. When Voyager 2 made its own crossing years later, it hit the boundary at a different distance entirely. This confirmed that our solar system is not enclosed in a neat, uniform sphere. The heliosphere is shaped like a blunt bullet. It is an asymmetric, distorted structure that is constantly being reshaped by the environment it moves through. Because the sun moves through the galaxy at 490,000 miles per hour, the interstellar medium acts as a headwind. This force compresses the nose of our solar system while stretching the tail out for billions of miles behind us. Our solar system is not a stationary bubble. It is a high-speed object aggressively plowing its way through the Milky Way. Scientists once assumed that leaving the solar system would be a sudden, clean exit. The reality was a prolonged and messy transition. Voyager 1 discovered what researchers call the magnetic highway. In this region, the sun's magnetic field lines merge with those of the galaxy, creating a bridge where solar particles and galactic cosmic rays flow past each other in both directions. This edge is also dynamic. It breathes. Voyager recorded the boundary washing back and forth over its position, meaning the physical end of the solar system was expanding and contracting in real time. These movements are caused by solar storms. When the sun has a major outburst, the surge in pressure pushes the entire boundary of the solar system further out into the void. Even in the deep interstellar medium, Voyager detected tsunami waves, shock waves from solar events that happened years earlier, still rippling through the galactic gas. The sun's influence does not end at a fixed coordinate. Its energy reaches out into the unknown galaxy, disturbing the interstellar environment billions of miles beyond the heliosphere. Today, the Voyager probes are the furthest man-made objects in existence, but they are operating on the edge of technical failure. Their plutonium power sources are decaying by about 4 watts every year. To keep them functioning, engineers have been systematically shutting down non-essential systems to conserve every possible drop of energy. By the early 2030s, the power will likely drop below the level required to run the transmitters. When that happens, these massive dishes will hear nothing but static from the Voyager coordinates. The mission proved that even our most sophisticated theories are only approximations of a much more complex reality. The universe is more dynamic than our models predicted. For the next 40,000 years, these probes will drift silently through the dark, carrying the golden record, a time capsule of sounds, images, and greetings from a planet they left half a century ago. Science rarely moves in a straight line. It moves when a 50-year-old probe discovers something our best theories never predicted. If you want to follow that process of finding surprises in the data, subscribe.